In this video on recurrence relations, we have t1 to t6 defined by tn plus 1 is equal to a quarter of the previous term, and we're given t1 is 144. So when n is equal to 1, we're going to get term 2. It's going to be a quarter of term 1, quarter of 144. If you want to put t1 in there, you can initially. And a quarter of 144 is 36. When n is equal to 2, we're going to get term 3, which is going to be, I wrote a half there, not a half, a quarter. Thank you all for pointing out my mistake. A quarter of 36, which is going to be 9. Term 4, we're looking for the first 4 terms, going to be a quarter of 9. You can shorten it down, which is going to be 2.25. S infinity, we're going to see this a lot in the next section of videos where they get a little bit trickier. Sn is equal to a times 1 minus r to the power of n over 1 minus r. And the sum to infinity of these sequences that get smaller and smaller is just going to be a over 1 minus r. So if we write out the first 4 terms, 144, 36, 9 and 2.25. A is 144 and my ratio is a quarter, so we're going to have 144 divided by 1 minus 1 over 4, which works out to be 192. Just double check that on a calculator. 192 I think for this one. In question 6, they're in terms of x, and we have the first term 0.2, and we have an or here as well, but it doesn't really matter what letters they use. If or is equal to 1, we're going to get x2, which is equal to x or is 1, times 2 minus 4 times x or, which is x1. So maybe for the first stage you could do it like this. x1 is 0.2 times 2 minus 4 times 0.2 is 0.8. So 0.2 by 1.2 is 2 12s or 24 with 2 decimal places, so 0.24. When or is equal to 2, we're going to get x3. We're asked to find x2 and x3, so it's going to be x2 times 2 minus 4 times x2, which is equal to 0.24 times 2 minus 4 24s are 96, so 0.96. So that's 0.24 by 1.04, and adding 4% to 0.24, it's going to be 96. So I think this is 0.2496. Always double check on a calculator. So that's x2 and x3. In this recurrence relation, we're given u1 is equal to 0 and u2 is equal to 1, so we obviously need these two. So we're asked to find u4, so we better get u3 first. N is equal to 2 to get u3. u3 is going to be equal to un, which is 2, plus the square root of un, which is u2, times un minus 1, which is u1. That's why we had 2 of them. So there's 2 unknowns here, and we have 2 on the bottom. So u2 is 1 plus the square root of u2, 1, well, times 0 is going to just give 0 over 2. So this is just going to give a half for u3. u4 now in this form, we need a square root inside it. So if n is equal to 3, we get u4. u4 is equal to un, which is u3, bring it back down, plus the square root of u3 times u2, and it's all divided by 2. So this is going to be equal to u3, which was a half, plus the square root of u3, which is a half, times u2, which is 1, all divided by 2. And to get it in the form a plus b root c, I'm just going to type this into a calculator. So it's giving me 1 plus root 2 over 4. 1 plus square root of 2 divided by 4, which can be written in different forms, but this is the way I'm going to leave it.